Section 8, Part 1 of the Introduction to Timaeus. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Patty Cunningham. Timaeus by Plato. Translated by Benjamin Jowett. Introduction and Analysis. Section 8, Part 1. We have now to consider how far in any of these speculations Plato approximated to the discoveries of modern science. The modern physical philosopher is apt to dwell exclusively on the absurdities of ancient ideas about science, on the haphazard fancies and a priori assumptions of ancient teachers, on their confusion of facts and ideas, on their inconsistency and blindness to the most obvious phenomena. He measures them not by what preceded them, but by what has followed them. He does not consider that ancient physical philosophy was not a free inquiry, but a growth in which the mind was passive rather than active, and was incapable of resisting the impressions which flowed in upon it. He hardly allows to the notions of the ancients the merit of being the stepping stones by which he has himself risen to a higher knowledge. He never reflects how great a thing it was to have formed a conception, however imperfect, either of the human frame as a whole or of the world as a whole. According to the view taken in these volumes, the errors of ancient physicists were not separable from the intellectual conditions under which they lived. Their genius was their own, and they were not the rash and hasty generalizers which since the days of Bacon we have been apt to suppose them. The thoughts of men widen to receive experience. At first they seem to know all things as in a dream. After a while they look at them closely and hold them in their hands. They began to arrange them in classes and to connect causes with effects. General notions are necessary to the apprehension of particular facts, the metaphysical to the physical. Before men can observe the world, they must be able to conceive it. To do justice to the subject, we should consider the physical philosophy of the ancients as a whole. We should remember, 1. That the nebular theory was the received belief of several of the early physicists. 2. That the development of animals out of fishes who came to land, and of man out of animals, was held by Anaximander in the 6th century before Christ. Compare Plutarch, Symposiacs 8, question 8. 4. De Placitis Philosophorum v. 19:1. 3. That even by Philolaus and the early Pythagoreans, the earth was held to be a body like the other stars revolving in space around the sun or a central fire. 4. That the beginnings of chemistry are discernible in the similar particles of Anaxagoras. Also, they knew or thought. 5. That there was a sex in planets as well as in animals. 6. They were aware that musical notes depended on the relative length or tension of the strings from which they were emitted, and were measured by ratios of number. 7. That mathematical laws pervaded the world, and even qualitative differences were supposed to have their origin in number and figure. 8. The annihilation of matter was denied by several of them, and the seeming disappearance of it held to be a transformation only. For although one of these discoveries might have been supposed to be a happy guess, taken together they seem to imply a great advance and almost maturity of natural knowledge. We should also remember, when we attribute to the ancients hasty generalizations and delusions of language, that physical philosophy and metaphysical too have been guilty of similar fallacies in quite recent times. We by no means distinguish clearly between mind and body, between ideas and facts. Have not many discussions arisen about the atomic theory in which a point has been confused with a material atom? Have not the natures of things been explained by imaginary entities, such as life or phlogiston, which exist in the mind only? Has not disease been regarded, like sin, sometimes as a negative and necessary, sometimes as a positive or malignant principle? The idols of Bacon are nearly as common now as ever. They are inherent in the human mind, and when they have the most complete dominion over us, we are least able to perceive them. We recognize them in the ancients, but we fail to see them in ourselves. Such reflections, although this is not the place in which to dwell upon them at length, lead us to take a favorable view of the speculations of the Timaeus. We should consider not how much Plato actually knew, but how far he has contributed to the general ideas of physics, or supplied the notions which, whether true or false, have stimulated the minds of later generations in the path of discovery. Some of them may seem old-fashioned, but may nevertheless have had a great influence in promoting system and assisting inquiry, while in others we hear the latest word of physical or metaphysical philosophy. There is also an intermediate class, in which Plato falls short of the truths of modern science, though he is not wholly unacquainted with them. 1. To the first class belongs the teleological theory of creation. Whether all things in the world can be explained as a result of natural laws, or whether we must not admit of tendencies and marks of design also, has been a question much disputed of late years. Even if all phenomena are the result of natural forces, we must admit that there are many things in heaven and earth which are as well expressed under the image of mind or design as under any other. At any rate, the language of Plato has been the language of natural theology down to our own time, nor can any description of the world wholly dispense with it. The notion of first and second, or cooperative causes, which originally appears in the Timaeus, has likewise survived to our own day, and has been a great peacemaker between theology and science. Plato also approaches very near to our doctrine of the primary and secondary qualities of matter. 61 ff. 2. Another popular notion which is found in the Timaeus is the feebleness of the human intellect. God knows the original qualities of things. Man can only hope to attain to probability. We speak in almost the same words of human intelligence, but not in the same manner of the uncertainty of our knowledge of nature. The reason is that the latter is assured to us by experiment, and is not contrasted with the certainty of ideal or mathematical knowledge. But the ancient philosopher never experimented. In the Timaeus, Plato seems to have thought that there would be impiety in making the attempt. He, for example, who tried experiments in colors, would forget the difference of the human and divine natures. 68d. Their indefiniteness is probably the reason why he singles them out as especially incapable of being tested by experiment. Compare the saying of Anaxagoras, Sextus, Outlines of Pyrrhonism, I. 33, that since snow is made of water, and water is black, snow ought to be black. The greatest divination of the ancients was the supremacy which they assigned to mathematics in all the realms of nature, for in all of them there is a foundation of mechanics. Even physiology partakes of figure and number, and Plato is not wrong in attributing them to the human frame, but in the omission to observe how little could be explained by them. Thus we may remark in passing that the most fanciful of ancient philosophies is also the most nearly verified in fact. The fortunate guess that the world is a sum of numbers and figures has been the most fruitful of anticipations. The diatonic scale of the Pythagoreans and Plato suggested to Kepler that the secret of the distances of the planets from one another was to be found in mathematical proportions. The doctrine that the heavenly bodies all move in a circle is known by us to be erroneous, but without such an error, how could the human mind have comprehended the heavens? Astronomy, even in modern times, has made far greater progress by the high a priori road than could have been attained by any other. Yet strictly speaking, and the remark applies to ancient physics generally, this high a priori road was based upon a posteriori grounds, for there were no facts of which the ancients were so well assured by experience as facts of number. Having observed that they held good in a few instances, they applied them everywhere, and in the complexity of which they were capable, found the explanation of the equally complex phenomena of the universe. They seemed to see them in the least things as well as in the greatest, in atoms as well as in suns and stars, in the human body as well as in external nature. And now a favorite speculation of modern chemistry is the explanation of qualitative difference by quantitative, which is at present verified to a certain extent, and may hereafter be of far more universal application. What is this but the atoms of Democritus and the triangles of Plato? The ancients should not be wholly deprived of the credit of their guesses because they were unable to prove them. may they not have had, like the animals, an instinct of something more than they knew? Besides general notions, we seem to find in the Timaeus some more precise approximations to the discoveries of modern physical science. First, the doctrine of equipoise. Plato affirms, almost in so many words, that nature abhors a vacuum. Whenever a particle is displaced, the rest push and thrust one another until equality is restored. We must remember that these ideas were not derived from any definite experiment, but were the original reflections of man, fresh from the first observations of nature. The latest word of modern philosophy is continuity and development, but to Plato this is the beginning and foundation of science. There is nothing that he is so strongly persuaded of as that the world is one, and that all the various existences which are contained in it are only the transformations of the same soul of the world, acting on the same matter. He would have readily admitted that out of the protoplasm all things were formed by the gradual process of creation. But he would have insisted that mind and intelligence, not meaning by this, however, a conscious mind or person, were prior to them and could alone have created them. Into the workings of this eternal mind or intelligence he does not enter further, nor would there have been any use in attempting to investigate the things which no eye has seen nor any human language can express. Lastly, there remain 2 points in which he seems to touch great discoveries of modern times: the law of gravitation and the circulation of the blood. 1. The law of gravitation, according to Plato, is a law, not only of the attraction of lesser bodies to larger ones, but of similar bodies to similar, having a magnetic power as well as a principle of gravitation. He observed that the earth, water, and air had settled down to their places, and he imagined fire, or the exterior ether, to have a place beyond air. When air seemed to go upwards and fire to pierce through air, when water and earth fell downward, they were seeking their native elements. He did not remark that his own explanation did not suit all phenomena, and the simpler explanation, which assigns to bodies degrees of heaviness and lightness proportioned to a mass and distance of the bodies which attract them, never occurred to him. Yet the affinities of similar substances have some effect upon the composition of the world, and of this Plato may be thought to have had an anticipation. He may be described as confusing the attraction of gravitation with the attraction of cohesion. The influence of such affinities and the chemical action of one body upon another in long periods of time have become a recognized principle of geology. 2. Plato is perfectly aware, and he could hardly be ignorant, that blood is a fluid in constant motion. He also knew that blood is partly a solid substance consisting of several elements, which, as he might have observed in the use of cupping glasses, 79e, decompose and die when no longer in motion. But the specific discovery that the blood flows out on one side of the heart through the arteries, and returns through the veins on the other, which is commonly called the circulation of the blood, was absolutely unknown to him. End of Section 8, Part 1. Recording by Patty Cunningham.